Okay, we have seen so far that the database development process consists of several stages, and out of those stages, the two major ones that we have concentrated on, one is conceptual data modeling and the other is database design. And the previous few video tutorials, we had been focusing on the first of those two, namely conceptual modeling. And just to remind us in terms of, or to summarize what we learned from those discussions, is that when you're doing conceptual data modeling, what you're essentially doing is taking the requirements of the database, that is requirements of what is going to be contained in the database, and then you're trying to express that content in a very structured way. Specifically, what you're trying to do is express the content of the database in terms of the things about which you're going to store information, namely the entities about which you're going to store information, and also the relationships among those different entities. Okay, so at this stage, when you're doing conceptual modeling, you're not worried about what specific software package you're going to use to represent or to implement the database and so forth. That will come later. Okay, and then most of the tutorials after that, what we discussed was the symbols that are used to do conceptual data modeling or the entity relationship data modeling, because the data model is represented pictorially, and you can see an example of that in front of you. We used this picture in one of the earlier tutorials. But we went through and discussed all the different symbols that are used in this picture and what these symbols mean in terms of drawing the picture. Okay, so in this tutorial, what I want to do is reinforce those concepts in terms of the symbols that are used to express a conceptual data model, just to reinforce those concepts through revisiting this particular diagram, again this entity relationship diagram here. So what you see before you is a picture, and it is a conceptual data model. So let me write that here, just you should remember that. So this is a conceptual data model for some application. Okay, and again, to remind us, what does the conceptual data model do? It expresses the content of the database in a very structured way. Why very structured? So, we could just as well, in principle, express the content of the database in plain English, but it'll be very hard to understand what's going on within the database if we don't give it some structure, and we won't be able to extract information from it anyways. Okay, so the main important thing here is that the content of the database is represented in a very structured way, hence the words data model. And the very structured way in which we represent the conceptual data model is called an entity relationship model. Why? Because there are two major components to that structure. One is entities and the other is relationships. And we spent a lot of time in the prior videos discussing various aspects of entities and various aspects of relationships. So we're trying to reinforce those concepts through this picture. First thing, so let's take it one piece at a time. So there, as we said, there are two major components of a conceptual data model. One is entities and the other is relationships. So let's look at each in turn. So again, this is a reminder. An entity is represented by boxes, rectangles. Okay, so you see an entity here, you see an entity here, customer, meter, reading, and so forth. Okay, so every entity is represented by a rectangle. Now notice that there is one entity over here that looks just a little bit different. Do you see that there are some cut marks on the corners? So they don't look exactly the same. So this entity doesn't look exactly the same as all the other entities. If you look around all the other 6 entities, they just look like regular rectangles. This entity called rate also is a rectangle, but has a slightly different look in that the 4 corners have cuts on them. And we'll come back to that in a little bit. Okay. So first thing is entities are represented by rectangles. Every entity must have a name. Every entity must have a name, and more specifically, these rectangles that you're seeing are what are called entity classes. So maybe you can remind yourself what an entity class is. An entity class is just a sort of a template of the object or thing about which you're going to store information. So you have entity classes and entity instances. For example, when you look at this rectangle called customer, this rectangle, customer is the entity class. And then when you look, and so this box gives you a general template for what a customer looks like. And then when you look at each customer separately, that would be an entity instance. So you have multiple instances of customer. Okay. So entity class, entity instance. So those are two aspects of entities. And we just said every entity must have a name. And you can see that in boldface. All right. Next thing about an entity is every entity must have an identifier. So it is an attribute, or sometimes it's a combination of attributes that uniquely identifies every entity instance. So here you can see, and the identifiers are usually underlined. So every entity must have an identifier also, and that is typically underlined. As it so happens in this diagram, all the entities have identifiers that consist of one attribute, but you could have an entity that has an identifier that is compound, that is has composite identified, consists of more than one attribute. Okay, all right. So identifier, that's another aspect of entities. Okay. The third aspect of entities is that every entity has attributes. Okay, so these are properties of the entity, and they're typically written within the box. So if you look at the entity called customer, it has customer number as the ID, as the identifier, and then you have customer name and customer type. Okay. If you look at this entity called reading, the identifier is reading number, and then you have the reading time, what time the meter was read, and the reading level, what the actual value of the meter reading was. Okay, so every entity must have attributes as well. All right. Now, when we draw the ER diagram, when we draw a diagram like this, sometimes if there are a lot of entities in the diagram, in many practical situations, the diagram can get pretty large. Then just to conserve space and to reduce clutter, sometimes the entities are drawn just as boxes with the name of the entity, but they don't show the attributes. The attributes are kind of hidden. Okay, and maybe when you click on the box, then it blows up and it expands and shows you the attributes. But just to conserve space visually, sometimes the attributes are not shown, but technically the attributes have to be there, whether they're shown or not. Every entity must have attributes. All right. So in terms of this first piece of the conceptual data model, or the entity relationship data model, we talked about entities and all the different aspects of entities, the concepts surrounding this thing called an entity. Now let's look at relationships. So you can see that some of these entities are connected by lines. Okay, so there are many relationships are complex. It's a complex concept, meaning it has a lot of aspects to it. So we will see each of those things in turn. The first aspect of a relationship is, first of all, how do you show it visually? They are shown visually by lines. Okay, so let me see, maybe I'll just insert a fresh slide so I can write cleanly on it. Okay, so we're talking about relationships here. They're represented by lines. Okay, so let's come back to the picture. So you can see a line from rate set to customer. You can see a line from customer to meter. By the way, by now, by looking at the different entities, I hope you have inferred that the application for which this database is being built is some kind of utility billing. So you have customers and they consume utilities. The utilities could be gas, it could be electricity, it could be water. And there are different meters for the customer. There's a water meter, there is a gas meter, there may be an electric meter. Okay, and these meters are read periodically, maybe every month, maybe every 2-3 months, by employees of the utility company, okay, from which bills are generated. So that's the general application for which this database is being designed. So coming back to relationships that we were discussing, you can see that there are lines among certain entities. So relationships are represented by lines. All right. So however, you can see these lines are dotted lines. Do you see this? Here's a dotted line here, a dotted line here, a dotted line here, a dotted line here. However, you have a solid line over here. All right. So let's say lines usually dotted. Okay. Occasionally solid. So we'll come back and discuss when the line should be solid. So what are the aspects of relationships that we need to remember? One is the degree of the relationships. Okay, that is how many entities does it connect. Okay, so coming back to our picture, and by the way, every relationship must have a name. So you can see you have this relationship called assigned. Okay, so a rate set is assigned to customer. So you have another relationship called uses. So a customer uses meters, and then read by, a meter generates a reading when it is read. Okay, so every relationship must have a name. Again, you can see that name written next to the line, somewhere either on the line or close to the line. Okay, so coming back to the degree of the relationship, the degree of a relationship is how many entities is the relationship connecting. And by far the most common type of relationship is the binary relationship. So relationship connects two entities. All right. So if you look at assigned, uses, read by, performs, includes, contains, it just so happens that in this particular data model, all the relationships are binary, and that's by far the most common one. However, just remember that you can also have unary relationships. We'll see later on examples of that, or recursive relationships. And you can also have higher order, higher degree relationships that could be ternary. So connecting three entities or even more. But for all practical purposes, this is binary, covers maybe 95% of the type of relationships that you will run into, and occasionally you might run into unary. Okay, so one aspect of a relationship is the degree, and it so happens that in this particular data model, each and every relationship is binary. Okay, now the other aspect of a relationship, and this is the more complicated aspect of a relationship, is the cardinality of a relationship. Okay, so just remember the word cardinality is just a fancy way of saying count, how many. Okay, how many, and you have a maximum and a minimum cardinality always, okay, for every relationship. So let's go back and see what these, how these are represented. And there are three different types of cardinalities that you could get in a binary relationship. You have a one-to-one, one-to-many, and many-to-many. Okay, so let's see what that means. These are the maximum cardinalities that you could have. Okay, so let's see what that means and how it is physically represented. Cardinalities are always represented by symbols at the two ends of the relationship line. Okay, so remember we said that a relationship is represented using a line, and most of the time it's a dotted line. So just to avoid clutter, I'm not writing the name of the relationship. So just imagine that this dotted line is some kind of a relationship between two entities here. The cardinalities are always shown at the two ends of the relationship line. Okay, so I have circled some of them here. These, you can see all these cardinalities. Okay, now if you focus on any one of these ends, so let's say focus on this one, and I focus over here. So I'll draw them in this picture over here. So let me erase this circle here just to give me some space. And okay, so here, so I'm just expanding the picture just to have be making easier to discuss. So I've taken these two symbols at the two ends of this line called assigned. One is the rate set and the other is customer, or for that matter, let me take customer and meter actually. So again, you have the same symbols. You have two vertical bars and you have this particular symbol here. So let me write, this is customer and this is meter. So we're talking about cardinalities here. The way to interpret these pictures is you look at the two outside symbols, the outer symbols. Okay, these are the outer symbols. And you look at the inner symbols. Okay, so the outer symbols represent the maximum cardinalities and the inner pair of symbols represents the minimum cardinalities. So now what does that all mean? What is this picture telling us? All right, so let's go from, anytime you're trying to interpret cardinalities, you have to go in both directions, meaning from the left side entity to the right side, as well as from the right side entity to the left side. So you have to go from one entity to the other and in reverse directions both to be able to interpret the cardinalities. So let's go ahead and try and interpret this picture. So I'll start with the outer symbols first, the outer pair of symbols first. So one customer, okay, so going back to the picture, the relationship is users, right? So if I look at the outer pair of symbols, we'll say one customer uses at most many meters. Okay, so one customer uses at most many meters. Where did the many come from? You see this crow's foot at the end? The crow's foot is just sort of a corrupted version of the letter M. Okay, so many. Okay. So one customer uses at most many meters because the outer symbols represent the maximum cardinality. Now if I go in the reverse direction from meter to customer, we'll say 1 meter is used by at most 1 customer. So I start from meter and I go to customer, and I'm only looking at the outer symbol. The outer symbol is a 1, isn't it? This vertical line is a 1. So 1 meter is used by at most 1 customer. So if I go from customer to meter, I'll say 1 customer uses at most many meters, but 1 meter is used by at most 1 customer. Now when I look at the inner pair of symbols, that is the at least, it's the minimum cardinalities. So when I go from left to right, when I go from customer to meter, I will say 1 customer uses at least 0 meters. So it's possible that a customer has its own source of, is using firewood and doesn't use electricity, maybe living off the grid. So it's possible that a customer does not have a meter. It's not using any meter utilities. Okay, so one customer uses at least, so that's the minimum we're talking about, at least 0 meters, because this is the inner symbol. This O is a 0. Okay, and when I go in the reverse direction from meter to customer, again I will look now at the inner symbol because we're talking about the minimum cardinality. We will say 1 meter is used by at least one customer. So if there is a meter, there must be a customer associated with it. Okay, so a customer need not have a meter, but if there is a meter, it has to be associated with at least one customer. All right, so I hope you understand now what those two symbols mean, the minimum and the maximum cardinalities. Now let's go back to the to the picture over here. Now let's look at the relationship between meter and reading. Now informally, you know that an electric meter or a gas meter or a water meter is read many times, right? Perhaps every month. So that's why you can see this relationship here. Let's go from meter to reading. We'll say 1 meter is read at most many times. Do you see this crow's foot here? I'm looking at the outside symbols. And then when I go in the reverse direction, one reading, if I go from here to here, one reading is associated with at most 1 meter. Okay, you can't have one reading for multiple meters. So one reading is associated with at most 1 meter. Now, if I look at the inside symbols, the minimum cardinalities, I will say that 1 meter is associated with at least 0 readings. It's possible you have a meter that has not been read yet. All right, so you can try it on your own. Look at this entity relationship diagram and try to verbalize each one of these relationships in terms of the cardinalities. It will give you practice in terms of interpreting minimum and maximum cardinality. Now there is one little piece left here in this picture that I kept hanging till the end, and that is this relationship. So far we have said that all relationships, most of the time, they are represented by dotted lines. Okay? But occasionally it's a solid line like you see over here. And the entity, this entity called rate, I just mentioned at the beginning of this tutorial that it looks a little bit different from the rest because it's got this cut off corners at the end. So what's going on about that? So there, the concept that comes into play is a twist on the concept of an entity that we discussed in our last tutorial, I think, and that's the concept of a weak entity. Okay, so a weak entity is simply an entity that cannot exist by itself. Okay, it can only exist in conjunction with another entity. So what we are saying here is that a rate can only be associated with a rate set. Okay, so so unless there is a rate set, you cannot have a rate. So this entity called rate can only be associated, can only exist if there is a rate set. And this often happens with utilities. That is, you have a certain collection of rates. So rates, you have rates for the summer, you have rates for the winter, for example, and just to discourage excessive electricity usage in the summer, the per unit charge may get increased in the summer for electricity and so forth. So utilities very rarely have one set of rates even for the same commodity. So they have sets of rates, and within those sets they will have different rates. So if you use more, the per unit charge becomes less. If you use less, the per unit charge is more. So there are different rates within each set. You don't need to be an electricity expert to interpret this. For our purposes, the important thing to understand is that this entity called rate is a weak entity. It can only exist because it's associated with rate set. It cannot exist on its own. It only exists when rate set exists. So to signify the fact that it's a weak entity, it's not just any kind of entity, it's not a regular entity, it's a weak entity. That's why you got these special marks around around the corner over here. And also the connection between the two entity rate set and the weak entity called rate is by a continuous line, because if you recall that a weak entity, there are two variations of the weak entity. One is ID dependent, and the other one was non-ID dependent. Okay, so this one is a non-ID dependent type of weak entity. You can go back to the previous tutorial and review what the difference is between an ID dependent weak entity and a non-ID dependent weak entity. But anyway, for our purposes here, what is useful to remember is that a weak entity is a slight variation of an entity, and it exists only when the strong entity to which it is related exists. And so this relationship called contains is a special kind of relationship, and it is drawn with a continuous line. Okay, so hopefully this example has reinforced the concepts and the symbols that are used to represent a conceptual data model, which is an entity relationship diagram. Okay, in the next tutorial, we'll look at a fairly comprehensive example from start to finish and actually build an entity relationship diagram like this. So throughout the discussion that we had just now, I didn't tell you why we have 7 entities in this model, why we have the particular relationships that we do, what is it in the application that made us create 7 entities. So the modeling process itself, I haven't discussed. All I showed you is, okay, we went through a modeling process and we came up with this conceptual data model, and we are drawing it as a picture, namely an entity relationship diagram. And what I was trying to do is explain what the different symbols are, what are the different concepts associated with an entity relationship data model, and how would you interpret the model pictorially when one is presented to you.